Good day, everyone. Allow me to present the findings of our study entitled Assessment of Conceptual Knowledge and Error Analysis in Mathematics Among Pre-Service Teachers. We are from the University of Eastern Philippines Laoang campus. Assessing conceptual knowledge and conducting error analysis in mathematics among pre-service teachers is key to achieving SDG 4 quality education. It helps identify knowledge gaps, ensuring future teachers understand mathematical principles deeply. This focus improves teaching quality, promotes critical thinking, and enhances learning outcomes, aligning with SDG 4's goal of providing inclusive and equitable quality education for all. Mathematics education often faces challenges in ensuring students develop a deep understanding of mathematical concepts. Many students struggle with conceptual knowledge and the ability to grasp underlying principles and apply them to various problem-solving situations. While the study provides valuable insights into the conceptual knowledge and common error patterns among pre-service mathematics teachers, it primarily focuses on identifying and categorizing errors without thoroughly exploring the underlying causes of these errors. Additionally, the research does not extensively investigate the effectiveness of specific instructional strategies in mitigating these errors and enhancing conceptual understanding. Future studies could address these gaps by examining the root causes of errors in greater detail and testing various instructional interventions to determine the most effective methods for improving conceptual knowledge and reducing mathematical errors among pre-service teachers. Objectives: to address this issue, this study aimed to assess the level of conceptual knowledge of the respondents in mathematics, identify specific errors committed by the respondents, and determine the relationship between the level of conceptual knowledge and the errors committed. Methods: a descriptive correlational research design was utilized. The study involved all pre-service teachers who were present during data collection. A researcher-made questionnaire was used to gather data, which were then analyzed using frequency counts, percentages, and Pearson correlation. Results and discussion. The results indicate that most pre-service teachers have moderate to low conceptual knowledge in mathematics. Specifically, 16% showed high conceptual knowledge, 44% had moderately high knowledge, 32% exhibited low knowledge, and 8% had very low knowledge. These findings highlight the need for targeted interventions to enhance their conceptual knowledge and overall proficiency in mathematics. The analysis of the errors committed by the pre-service teachers revealed several common areas of difficulty. These errors were categorized into different themes based on the nature of the mistakes. Key findings include explanation and justification errors. Students struggled with explaining and justifying their answers, particularly in topics like multiplication of integers and operations with unlike sign numbers, calculation errors. Errors were frequently made in perimeter calculations, finding algebraic patterns, and performing operations involving division by zero, comparison and conversion errors. Students had difficulty comparing percentages and decimals, as well as simplifying radical expressions and converting units of measurement, concept definition errors. There were notable errors in defining mathematical concepts such as sets and circles, as well as converting radical numbers to rational numbers, algebra and geometry errors. Common mistakes were found in algebraic expressions, measuring triangle angles, and simplifying fractions with negative exponents. These errors highlight specific areas where the pre-service teachers need further support and instruction. The identification of these common mistakes provides valuable insights for educators to target these areas and improve students' conceptual understanding and mathematical proficiency. The results from Table 2.1 reveal that most respondents struggled with explaining how to multiply integers, with 56% making errors in encoding. Other errors included 12% in transformation, 4% in comprehension, and 4% in process skills. These findings highlight the need for targeted instructional strategies to address specific difficulties, particularly in encoding mathematical procedures, to improve students' overall understanding and proficiency in mathematics. Table 2.2 shows that students struggled significantly with the operation of unlike sign numbers, with 20% committing transformation errors, 12% process skill errors, and 24% encoding errors. This indicates a need for focused instructional strategies to address these specific difficulties, particularly in transformation and encoding, to improve students' understanding and proficiency in this area. Table 2.3 shows that students struggle with adding dissimilar fractions, with 4% making comprehension errors, 36% making transformation errors, and another 36% making process skills errors. These findings indicate that many students do not understand the need to convert dissimilar fractions to similar ones before addition. This highlights the need for focused instructional strategies to improve understanding and proficiency in this fundamental concept. Table 2.4 shows that students faced significant difficulties with the perimeter of a rectangle, with 24% making comprehension errors, 24% making transformation errors, and 36% making encoding errors. These findings highlight the need for targeted instructional strategies to improve students' understanding, particularly in the areas of comprehension, transformation, and encoding. Addressing these difficulties will help students develop a clearer and more accurate understanding of this fundamental mathematical concept. Cheung, 2019. Table 2.5 shows that students faced significant difficulties with algebraic patterns, with 4% making comprehension errors, 12% making transformation errors, 4% making process skills errors, and 56% making encoding errors. These findings highlight the need for instructional strategies to address specific difficulties in understanding and explaining algebraic patterns. Focusing on these areas can help students develop a stronger grasp of this important mathematical concept. Table 2.6 shows that students faced significant difficulties with the division rule by zero, with 4% making comprehension errors, 20% making transformation errors, 24% making process skills errors, and 36% making encoding errors. This indicates that many students struggled to justify why a number cannot be divided by zero. These findings underscore the need for targeted instructional strategies to address these specific difficulties, helping students develop a clearer and more accurate understanding of this fundamental mathematical concept. Table 2.7 shows that students faced significant difficulties in comparing percentages and decimals, with 20% making transformation errors, 8% making process skills errors, and 40% making encoding errors. These results indicate that many students struggled to justify the equivalence of 5% to 0.05. This highlights the need for focused instructional strategies to address the specific difficulties in transformation and encoding processes, helping students develop a clearer understanding and improve their mathematical proficiency. Table 2.8 indicates that students encountered difficulties with simplifying radical numbers, with 4% making process skills errors and 20% making encoding errors. This shows that some students struggled to explain that the simplest form of square root 49 is 7. These findings highlight the need for targeted instructional strategies to improve students' understanding and proficiency in simplifying radical numbers, helping them achieve a clearer and more accurate grasp of this mathematical concept. Table 2.9 shows that students faced significant difficulties in converting unit measures, with 12% making comprehension errors, 24% making transformation errors, 4% making process skills errors, and 36% making encoding errors. These results indicate that many students struggled to justify why 2.5 kilometers is equivalent to 2,500 centimeters. This underscores the need for focused instructional strategies to improve comprehension, transformation, and encoding processes, helping students develop a clearer understanding and proficiency in unit conversion. Table 2.10 shows that students had significant difficulties in defining a set, with 16% making comprehension errors, 4% making transformation errors, and 72% making encoding errors. These findings highlight the need for targeted instructional strategies to clarify the concept of a set and provide precise definitions, helping students improve their understanding and proficiency in this fundamental area. Table 2.11 indicates that students faced significant difficulties with exponential numbers, with 8% making comprehension errors, 40% making transformation errors, 4% making process skills errors, and 24% making encoding errors. This suggests that many students struggled to correctly transform 50 into 1. These findings highlight the need for instructional strategies to clarify the concept of exponential numbers, providing clear and precise definitions to improve students' understanding and proficiency in this area. Table 2.12 shows that students encountered significant difficulties in converting radical numbers into rational numbers, with 12% making comprehension errors, 20% making transformation errors, 8% making process skills errors, and 36% making encoding errors. These results indicate that many students struggled to justify the concept involved in this conversion. This highlights the need for focused instructional strategies addressing comprehension, transformation, process skills, and encoding to help students develop a clearer understanding and improve their proficiency in this critical mathematical concept. Table 2.13 shows that students struggled with operations involving logarithms, with 24% making comprehension errors, 28% making transformation errors, 28% making process skills errors, and 20% making encoding errors. These findings indicate significant challenges in understanding and applying the rules for logarithmic operations. The results underscore the need for instructional strategies that address these specific areas to improve students' understanding and proficiency in logarithmic operations. Table 2.14 shows that students faced significant difficulties with algebraic expressions, with 4% making comprehension errors, 12% making process skills errors, and 48% making encoding errors. These results indicate that many students struggled to clearly and accurately explain the rules of multiplying algebraic expressions. This highlights the need for targeted instructional strategies to improve students' understanding and proficiency in algebraic operations, particularly in comprehension, process skills, and encoding. Addressing these areas can help students develop a clearer and more accurate understanding of algebraic expressions. Table 2.15 shows that students faced significant difficulties with factoring algebraic expressions, with 20% making comprehension errors, 52% making transformation errors, 8% making process skills errors, and 4% making encoding errors. These results indicate that many students struggled to identify the appropriate method for factoring algebraic expressions. This highlights the need for targeted instructional strategies to improve students' understanding and proficiency in this area, addressing specific difficulties to help them develop a clearer and more accurate grasp of this important mathematical concept. Table 2.16 indicates that students faced significant challenges in constructing and defining a circle, with 12% making comprehension errors, 4% making transformation errors, and 68% making encoding errors. Although many could draw a circle, they struggled to accurately describe it. These findings highlight the need for targeted instructional strategies to improve students' abilities to construct and define geometric shapes, enhancing their overall understanding of geometric concepts. Table 2.17 shows that students struggled significantly with the angle measure of a triangle, with 12% making comprehension errors, 32% making transformation errors, 4% making process skills errors, and 40% making encoding errors. This indicates many students had difficulty explaining why the sum of all the angles of a triangle is 180. These results underscore the need for targeted instructional strategies to improve understanding of geometric principles, specifically the angle measures of triangles, helping students develop a clearer grasp and improve proficiency in this fundamental geometric concept. Table 2.18 shows that students faced significant difficulties with simplifying fractions with negative exponents, with 8% making comprehension errors, 56% making transformation errors, and 28% making process skills errors. These results indicate a majority of respondents struggled to understand the method for simplifying fractions with negative exponents. This highlights the need for targeted instructional strategies to improve understanding and proficiency in this area, helping students develop a clearer and more accurate grasp of this mathematical concept. Table 3 shows a significant negative correlation between the level of conceptual knowledge in mathematics and the number of errors committed by respondents are equals 0.7 for 7, p equals 0.000. This indicates that as students' conceptual knowledge increases, the number of errors they commit decreases. Conversely, those with lower conceptual knowledge are more prone to making mistakes. These findings suggest that improving conceptual knowledge can help reduce errors in mathematics. The null hypothesis Ho was rejected, confirming the significant relationship between conceptual knowledge and errors. Conclusions? 1. The pre-service teachers showed a moderate level of conceptual knowledge in mathematics, indicating a need for further instructional support. 2. Common errors were found in various mathematical areas, including multiplication of integers, operations with unlike sign numbers, perimeter calculation, and more, highlighting areas needing additional focus. 3. There was a significant negative correlation, suggesting that improving conceptual knowledge in mathematics can reduce errors and enhance overall mathematical proficiency. Recommendations. Based on the findings of the study, the following recommendations are proposed. Update the curriculum to incorporate more opportunities for conceptual learning and practice in mathematics. This will help students build a strong foundation in mathematical concepts. Ensure that additional resources are provided to support mathematics education. This includes making available tools and materials that enhance the learning experience for students. Offer further training programs for teachers on effective teaching strategies that focus on improving conceptual knowledge in mathematics. Well-equipped teachers can better guide students toward understanding complex mathematical concepts. Encourage parents to actively participate in their children's mathematics education. Providing a supportive and conducive learning environment at home can significantly enhance students' learning outcomes in mathematics. Thank you for listening.